Hello, I am Pushkar. I am discussing KVPY 2020 essay part 2 chemistry paper. Here is a question from stoichiometry. Strength of an H2O2 solution is labeled as 1.79 normal. Its strength can also be expressed closest to which volume? So we have to convert this normality into the volume strength. As we know, for H2O2, volume strength of H2O2, a very important formula is that 1 liter, 1 molar solution of H2O2 can give us uh, half mole of O2 gas, and that is equivalent to 11.2 liters. So from this we can get the formula that if it is 1 molar, that is going to give 11.2 liters. So basically the volume strength, the formula is volume strength is equals to molarity of aqueous H2O2 multiplied by 11.2. You can check out this formula that if it is 1 liter of 2 molar H2O2, it is capable of giving 1 mole of O2. And 1 mole of O2 STP has the volume of what? 22.4 liters, which is nothing but twice into 11.2 liters. So pretty straightforward. We have this formula. The formula is volume strength of H2O2 is equals to 11.2 into molarity. But we need to find the molarity, and we know that normality upon n factor is equals to molarity. But what is the n factor for H2O2? So H2O2, n factor of H2O2 means H2O2 can either act as an oxidizing agent. If it is an oxidizing agent, then its oxidation number should decrease. So from -2, so it should become what? It from -2 oxidation state or -1 oxidation state, it should become what? It should decrease. So it can become what? -2, and which is H2O. So if you balance this equation, you're going to get what? Twice of this. So that is twice of H plus n plus 2 electron. So the n factor is 2 for the H2O2 acting as an oxidizing agent. But if it is a reducing agent, it can also act as a reducing agent. Then it will give O2 plus twice of H plus 2 electron. In this, it will provide electrons. Once again, it has an factor of 2. So whether it is acting as an oxidizing agent, whether it is acting as a reducing agent, it's always going to be, the n factor is always going to be 2. So you can of course express its normality into molarity by using the n factor 2. Although I highly object to it because I don't like this personally, normality term for H2O2. But since KVPY is a very standard examination, it is asking, we have to take this, okay, that the n factor of H2O2 is 2. Why I'm saying this? Because H2O2 can also disproportionate. And if H2O2 can disproportionate, there in the disproportionation reactions, you could not say that the n factor of H2O2 is 2. So nevertheless, since in this problem normality is given and strength is also, you don't have any other choice but to take the n factor is equals to 2. Is that clear? Right, students? So take the n factor is equals to 2 and convert this normality into molarity and then get your answer. So this is normality is equals to 1.79. So 1.79, we can write 1.79 divided by 2 is equals to molarity, and hence the volume strength is equals to 1.79 upon 2 into 11.2. That is equals to 1.79 into, this is 5.6, close to which value? Nearly 10. Let us see what are the options. 20 volume, 5 volume, 10 volume, and 15 volume. So obviously our answer is 10 volume. That's our answer. So 5.6 into 1.79 is indeed 10.0024. Straightforward question, but it's a controversial question for me. I would say that I never like using the normality term for H2O2 because H2O2 can does a lot of things. It can be oxidizing agent as well as reducing agent, and sometimes it can disproportionate. To avoid confusion, I always advise students to always stay with the molarity concept of H2O2. But nevertheless, since it's a very reputed examination, it is asking about the normality, you'll have to do this, what we have done in this problem. Stay tuned for next questions. Thanks for watching.